Our work and leisure is requiring increased connectivity, leading to a huge expansion in digital networks. As the world's internet capacity grows, so do the opportunities to innovate every aspect of our lives. Global technology company ABB is applying the concept of innovation to its training facilities, with the aim of preparing graduates for a new world of work. The company's German trainees learn everything from advanced robotics programming to 3D printing and modeling. It's likely that their future will involve working with smart digital technology.
Every day we work with computers and we use a lot of programs in it. It is very important because, like when you see 10 years ago, the smartphone, we didn't have any. We had like Nokia phone. And now when you see we have smartphones, we can touch them and we can do everything with that. And I'm pretty sure that next year it will change a lot.
Around 800 apprentices train at this ABB facility in Berlin. When it was founded 65 years ago, emphasis was on traditional techniques of welding and metalwork. These have now been eclipsed by state-of-the-art digital and automation technology.
The industry is changing and the skills have to also change. World-class products and world-class technologies needs world-class experts, and we train them here.
At a time when the technological revolution is changing factories and offices, technology firms are finding that it's never been more important to ensure a skilled workforce is ready for the challenge. That's good for workers facing up to a new kind of labor market. And as the fourth industrial revolution gets underway, it's also good for business.
Training has always been absolutely key. It's not the first industrial revolution, and training has accompanied our colleagues over the decades, actually over the 125 years ABB has existed. So I guess we're not only focusing on our business, but we also have a role macroeconomically, macro-socially.
The skills learned in centres like these are crucial to the next generation research and development work that tech companies are bringing to market. Like ABB's smart sensor, which allows remote monitoring of industrial motors, or the Internet of Things interface software, both products developed by researchers in India. Translating cutting-edge training to cutting-edge research is one way of showing how the digital revolution can best be harnessed. European leaders are also challenging their citizens to dream big and create new concepts for the digital revolution. The European People's Party, or EPP group in the European Parliament, is working to boost funding in research and innovation to make it easier for visionaries to bring their ideas to market. German MEP Christian Ehler believes investing in innovation could contribute to solving some of the world's most intractable problems.
We put an emphasis in terms of the budget on innovation, and this is the biggest innovation program in the world. We are going after the big things for the first time. So cancer, for example, we have a huge problem with children cancer, and the program will have a mission that means a big effort, €1 billion, where we try to cure children cancer.
Ehler wants to speed up the approvals process so clever ideas can reach the market quicker.
Fast track means simply you go to the commission, you have a consortium, you have a brilliant idea, you have an innovative idea, and they tell you within 6 months whether you get funded or not.
Michal Boni co-authored legislation to boost internet connectivity. He says a 5G mobile system will drive innovation in a gigabyte society with the Internet of Things.
Could you imagine the self-driving cars without sending information in milliseconds? Could you imagine new health solutions as telemedicine platforms.
A former Polish minister for digitalization, Bonnie says the cloud can help companies large and small.
We need to engage, to encourage SMEs to use all possible digital tools. And this is one additional issue which is important when we are talking about cloud. This is the initiative on European Open Science Cloud, which will give the possibility to all centers of research, to all universities, to exchange information, data, and results of research.
Innovation is leading a constant improvement in e-government and e-health, cybersecurity, and urban planning.
E-government can give you the possibility to participate in decision-making processes on e-health. I think that it will be the game changer. If we will use 5G and also all those new applications and new opportunities, giving to us the personalized medicine, giving to us better, deeper diagnosis, and after this, better therapies.
And why not a European digital library or a university for innovation? MEPs say innovation is limitless in a digital world.
We have joint efforts in the big things, and I think that's an EPP idea, that we go on plastic in oceans, that we care about the next generation of IT, quantum computers. We want to have a quantum computer in 2030. So go after the big things, join efforts, and be competitive in a even more competitive global world.
We need as EPP to address our message on innovation as message addressed to all people, to every citizen, to every patient, to every resident of the small city and the big city, to every worker and to every entrepreneur.
Among the many innovations that are transforming our working world, drones are among the most useful and the most versatile. They're being used by first responders to save lives, by conservationists to protect the environment, and by scientists and researchers looking for new ways to preserve and protect our global habitat.
Year after year, we've seen drones being used in more places throughout the world. I think about first responders, who at this point have saved over 250 lives with drones. And I also think about rangers in Africa. With a drone, they can now manage and protect elephant populations in ways that keeps everyone, human and animals, out of harm's way. We see drones empowering organizations in new and creative ways every day, and the uses continue to expand.
DJI was founded on specific principles like empowerment and inspiration. As advanced as we've made a drone, it's ultimately a resource to fit people's needs. What always impresses me is how our users have taken this tool to turn their bold ideas into action. These people are more than just pioneers. They're proof that innovation isn't just driven by technology alone, but the people who use it.
What I love most about the stories of our drones is how they've inspired people to discover themselves. Many people have started their own businesses with drones. Those with limited or no mobility have found their wings with a drone, rediscovering the world and creating their own paths.
But it's not just drone operators who have big dreams for aerospace technology. Swiss 7th graders, Elias and Mark, represent a new generation whose ideas are ready to take flight. The classmates produced a written proposal detailing their concept for an electric-powered commercial aircraft and sent it to Airbus.
We are fascinated of the airplanes which are now in the world. They are flying, and yes, and then we also like the planes which will be in the future on the Earth.
Airbus Chief Technology Officer Grazia Vittadini was so impressed that she invited them to tour the head office in Toulouse.
These will be the customers and engineers and hopefully pilots of the future. And so it is important that we are on the same page. And definitely we see now in the younger generations a growing interest when it comes to environmental awareness and sustainability. And this is definitely where Airbus is. This is something big on our minds and into our hearts.
Prioritizing safety, connectivity, and zero-emission flight, the BOIS concept put them at the cutting edge of aerospace design. Future engineers like Elias and Mark might choose to look even higher than the skies for their career. Already, scientists are using the International Space Station to run experiments for a range of applications, including growing plants in microgravity. As well as solving Earth-based problems, biological experiments will help scientists work out how to feed astronauts on long-haul missions.
So the International Space Station, as its name suggests, is international, and basically it allows you to do very long duration experiments in the spaceflight environment. So looking at the effect of microgravity, low gravity, also exposure to the direct space environment. You can do research in all fields. You can study, of course, the astronauts, how they react to the space environment. So studying the changes in their physiology. You can study biology. So the cells, which would be cells from, say, human body, microbes, plants. You can study also physical sciences, materials science, fluid physics, and also, of course, you can look outside from the space station. You can look at the Earth, so you can do Earth observation. You can do also observation of the space environment. Nice thing is, because it's an international platform, all of the facilities, all of the instrumentation is shared. So that allows you then to do a lot of research and very internationally. So there's been about 3,000 experiments done over the lifetime of ISS. And those gave about 2,000 scientific publications. One of the areas, of course, of interest is astrobiology. Do microorganisms or microscopic animals in dormant state, can they survive exposure to the space environment? This is very important to see whether life could be transported from one planet to another on astronaut, or whether also if you have, for instance, microbes on a spacecraft going from the Earth to Mars, how do you prevent contamination? The other aspect is also, how did life originate? So there's a lot of studies on the chemistry which led to life, so which may have been going on the primitive Earth or on the surface of a comet. So we developed an instrument called EXPOSE, and this was put on the outside of ISS and allowed exposure to direct space environment for typically 18 months, 2 years. And what was found was, in fact, that many of the microbes and even simple animals such as tardigrades, these are water bears, could actually survive direct exposure to the space environment for 18 months or so. And so that was a very interesting finding. The other area, of course, is plant biology. And there was actually a whole series of experiments done over a 10-year period by a team of European and US scientists. And they looked at all sorts of aspects of plant biology. They looked at how plants responded to gravity, because what you can do on board of the ISS is you can effectively look at what happens in the absence of gravity. You can apply, using a centrifuge, artificial gravity, and then see what is the perception threshold for plants to gravity. And that was actually found to be, hundreds of normal Earth's gravity. So plants are very sensitive.
Space is also the ideal site to study the process of boiling. Boiling is encountered in many engineering fields, such as environmental applications and industrial chemical processes. Understanding the dynamics of boiling is essential to improve energy production and conversion in power plants, and design future space applications like cryogenic fuel storage and propulsion. Boiling occurs in a wide range of situations, but on Earth, its properties and effects are too fast to be accurately observed and measured. But experiments conducted in low-gravity environments like on the International Space Station, allow us to observe phenomena like phase transition and the onset of bubbles much more clearly.
We investigate these boiling processes in space mainly for two reasons. First of all, because today's design methods are based on empirical knowledge and not really reliable when choosing, for example, new fluids or sophisticated microstructured wall geometries. Doing experiments in zero-gravity environment has the big advantage that the boiling process takes place in slow motion. That means we can investigate more details with higher resolution than on Earth. Second, modern space technology makes use of more and more electronic devices that have to be cooled very efficiently. Flow boiling is an excellent process to do so. In a team of European scientists, we tested many different components and preliminary setups in our labs on ground, as well as in many parabolic flights. This has led to the final experimental setup of Ruby. Ruby is an experiment to study the basic heat and mass transport phenomena in pool boiling and flow boiling systems.
Performing tests in microgravity conditions is necessary to better understand the boiling process. Such studies may lead to the increased energy efficiency of several applications here on Earth, from power plants, thermal management systems used in electric vehicles, laptops, and smartphones. The opportunity to conduct experiments in space opens a new world for scientific possibilities. Even school students are able to book a place to transport their studies on the commercial SpaceX spacecraft. This moves our horizon from the Earth to the universe beyond. Our working world has been disrupted by technology to the extent that it's estimated 47% of today's jobs will disappear in the next 25 years. But data scientist is a profession that has a bright future.
Any company around the world is actually using data to improve their business. So the question is, how do they deal with that data? How do they manage these volumes of data that nowadays we are massively collecting? Data is the new oil, but it's also true that you have to extract oil, you have to transport oil, you have to do everything that we already did with oil.
Other jobs in demand include business translator, who works out the questions to ask a data scientist, and agile coach, who helps companies maximize their flexibility. Finding the right people to fill these positions is a competitive business.
Our competitors in talent search are not only companies of our sector, are all of the companies from different sectors. Today, we have to go to search for them, to find them, and to convince them so that they want to come to work for us.
A car has 100 million lines of code, more than an F-35 fighter jet. So one of the most important jobs of the future in the automotive industry is software developer. Spanish carmaker SEAT has trialed a program to give 5 production line workers intensive training in software programming.
I came to SEAT 9 years ago and have been in workshop 8 until today. Here in the electronics lab, we make sure the machines on the line work properly. Today I'm starting a new path.
The trainees start their intensive course a little nervously, but quickly adapt to the new environment. If this program is successful, it will open new careers to many other car workers.
Our goal is to show that we're able to get people like this so they can help us in different roles, potentially bringing additional value.
3 months into the 4-month program, and the trainees have exceeded the expectations of their teachers.
At SEAT, we believe in our internal talent, so to transform our employees means they'll be 100% committed to the company.
These 5 graduates were the first, but they won't be the last. The company is committed to working with its employees to keep ahead of the curve and enable as many as possible to retrain in jobs of the future. And it's not just humans that need to adapt to technology. Factories themselves are transforming. Industry is one of the world's largest consumers of power, so many factories are becoming self-sufficient by installing solar panels or their own renewable power plants. In the factory of the future, the boundaries between human and machine are more fluid, and their interaction becomes more intelligent. We'll see digital assistant systems such as augmented reality, gesture control, wearables, or cobots becoming commonplace, as well as industrial robots that can interact safely with their co-workers without needing protective space. Intelligent gripping systems are now indispensable in human-robot collaboration. With sensitive robotic hands controlled only by gestures, in the future, workers will not have to use programming or complicated software. The next few years will see human and machine getting even closer, with less separation between human work and machine work. Processes are being redefined and reinvented, so humans and machines can collaborate more intelligently. On the production line itself, robots are already taking a load off workers and completely taking over some of the more hazardous jobs. In this Siemens factory, hundreds of robots are working to produce cars. They can handle capacity ranging from 16 to as much as 550 kilograms. The fourth industrial revolution means that the most effective factories of the future will combine both human and machine ingenuity. But we're not likely to be competing with robots. Machines will still need people to design, program, and operate them. The future is about using worker skills in more clever ways. Logistics company DHL's vision is to integrate new technologies such as augmented reality and 3D printing into its warehouses. The company plans to use artificial intelligence and the Internet of Things to make its workload more efficient. Robotics and automation will reduce the need for workers on the ground, freeing them up to work in the e-commerce areas where there is an opportunity to build bigger markets. The workplaces of the fourth industrial revolution will use human ingenuity to deploy machines in the most effective and efficient ways. Instead of the grunt work of factory labor, workers will expand their problem-solving skills and fill higher tech jobs that provide better pay and more interesting positions. Now that's a clever idea. The idea of building intelligent automaton stretches far back into human history. Early science fiction promised human-like mechanical creatures. When a real robot debuted at the 1939 New York World's Fair, he was an object of awe and excitement.
And so, ladies and gentlemen, with a great deal of pride and pleasure, I present to you Electro, the Westinghouse Moto Man. Electro, come here. And here he comes, ladies and gentlemen, walking up to greet you under his own power. You see, all I need to do is to speak into this phone, and Electro does exactly what I tell him to do, sometimes. But I don't see why I'm telling Electro's story when he's perfectly able to tell his own. So let's listen and see what Electro has to say to us today. All right, Electro, will you tell your story, please?
Who? Me?
Yes, you.
Okay, Toots.
Robots of the 21st century come with a little less attitude, but far more functionality. Electro's skills were limited to being able to smoke a cigarette, blow up balloons, and move his hands and legs. Boston Dynamics' Atlas robot demonstrates almost human-like agility. As well as humans, robotic engineers take their inspiration from the natural world. The flick-flack spider, found on the edge of the Sahara Desert, can propel itself into the air by somersaulting and rolling. Festo's bionic wheel bot is designed to walk and roll like this spider. To start rolling, the bionic wheel bot bends 3 legs each on the left and right of its body to make a wheel. 2 legs extend to push the rolled-up spider off the ground and continuously push it forward. This prevents the bionic wheel bot from stopping and ensures it can move itself forward even on rough terrain. Like its natural role model, the artificial spider rolls faster than it walks. The robot can even climb uphill. Through developing robots like this, bionics experts are creating devices that can traverse difficult terrain. Festo's bionic flying fox is based on the only mammal in the world that can fly. This ultra-lightweight winged robot is able to move semi-autonomously in defined airspace. With a wingspan of 228 centimeters and a body length of 87 centimeters, the artificial flying fox weighs just 580 grams. Its wing kinematics mimic the natural flying fox, including an elastic membrane which continues from the wings down to the feet. Like the real thing, the bionic flying fox can control and fold its wings together individually. The flying fox is tracked by 2 infrared cameras that feed images to a master computer. This controls the flight and feeds algorithms to the flying robot, enabling it to learn from every flight and constantly improve its performance. Festo's Bionic Swift is an aerial robot that uses the agile swallow as its inspiration. To make maneuvers as true to life as possible, the wings of the robotic bird are modeled on the plumage of real birds. Individual membranes are made of an ultralight, flexible, but very robust foam. Like real swallows, the Bionic Swift travels in a flock, with 5 machines able to move in a coordinated and autonomous way, interacting with a radio-based GPS. Intelligent networking of flight objects contributes to technology that could be used in the network factory of the future. Geolocation data could streamline processes and anticipate bottlenecks. And flying robots could transport goods around warehouses. Not content with creating artificial creatures on the ground and in the air, Festo is also working on underwater robots. The bionic Finwave is able to swim collision-free through a pipe system made of acrylic glass, thanks to ultrasound sensors. In the same way dolphins and pilot whales find their way through dark and murky waters. With an undulating fin motion, the bionic Finwave swims confidently through the pipe, using 5 ultrasound sensors to constantly measure the distances to the walls and ensure it's propelling itself in the right direction. While Festo's impressive robot range is still in development, Boston Dynamics has brought its robots to the marketplace. After years of testing, Spot is now available for sale, attracting buyers who need a robot that can cover rugged and dangerous terrain that wheeled robots can't manage. Spot has 360-degree vision and obstacle avoidance. It can be driven remotely or taught routes and actions to perform autonomous missions. The American-based company plans to commercialize some of its other prototypes as well. Big Dog was developed for the American Department of Defense as a possible pack mule for soldiers in terrain too tough for wheeled vehicles. To help it navigate difficult paths, it has a variety of sensors, including a laser gyroscope and a stereo vision system. Little Dog has 4 legs, each powered by 3 electric motors. The legs have a large range of motion and the robot is strong enough to climb. Little dog sensors measure joint angles, motor currents, body orientation, and foot-ground contact. One of Boston Dynamics' earlier robots was Wildcat, which paved the way for its current technology. It was the fastest quadruped robot on Earth, able to reach speeds of 32 kilometers an hour while maneuvering and keeping its balance. Wildcat's main purpose was to push the boundaries of robot flexibility and speed. Petman is a tethered Boston Dynamics robot developed to test chemical protection suits. It's the first human-like robot that moves like a real person. And robots that move like people are an aim of South Korea's Naver Corporation. Their prototype, Ambidex robotic arm, can be controlled by a 5G network from anywhere in the world. It has cable-driven mechanisms that makes interactions with humans safer and has potential applications in manufacturing and defense. At just 2.3 kilograms, Ambidex weighs less than a human's arm. It can be operated at a speed of 5 meters per second and can carry up to 3 kilograms. The robot arms can support high-speed, wireless, real-time control from remote locations, using 5G brainless robot control technology. The arm is controlled over a 5G wireless link using complex sensors and the latest 5G data management. Advanced robotics technology has the potential to transform people's lives, making the human-robot partnership one of the keys to a better tomorrow. 86 million kilometers from Earth, the Mars Space Laboratory begins its descent to the Red Planet. It's heading for a landing target in the Aeolis Palus region of Gale Crater. Hurtling through the Martian atmosphere at a speed of 5.6 kilometers a second, the spacecraft's instruments are monitoring the atmospheric conditions and performance of its heat shield. As the heaviest craft ever to attempt a Mars landing, the laboratory experiences the highest heat flux and shear stress ever faced by a vehicle's heat shields. It pinpoints its target, a 3.5 billion-year-old crater, and carries out the most accurate Martian landing of any spacecraft. On board the laboratory is the Curiosity rover, a car-sized autonomous robot, specially designed to navigate the planet's rugged and rocky terrain. Curiosity's mission is to investigate the Martian climate and geology, search for evidence of microbial life, and provide data that can be used to plan a human expedition to Mars. Crammed with scientific instruments, the 899-kilogram rover is powered by a generator that produces electricity from the decay of radioactive isotopes. This should keep it alive for at least 14 years. Robots like Curiosity are helping scientists access places humans can't reach. But for a successful mission to Mars, the robots first need to be tested on Earth in the right conditions. The rocky deserts of Utah in the United States can be a good substitute for the Martian landscape. Scientists from the Robotics Innovation Center of the German Research Center for Artificial Intelligence test their robotic systems in Utah by simulating a complete mission sequence. Mission control is in Bremen, Germany, more than 8,000 kilometers away. The successful tests give scientists important insights into the robustness and mobility of their systems. Another robot being developed for space exploration is the Spacebok, a jumping space robot that flies like a spacecraft. Built by a Swiss student team, Spacebok follows the example of astronauts who found themselves hopping rather than walking on the moon due to its low gravity. The team is slowly increasing the height of the robot's repetitive jumps and have reached up to 1.3 meters in simulated lunar conditions so far. The prototype has performed so well that they even used it to play a live-action game of Pong, the classic video game. The Spacebok is just one of the innovative products tested at the European Space Agency's Planetary Robotics Laboratory. The lab supports research, development, and testing of the two main robot types used in planetary robotics: rover platforms and sample manipulation systems. It evaluates planetary probes before they even reach the drawing board stage, saving time and money. There are many exciting innovations in the pipeline, from transformer robots that can convert their wheels to legs, to a robot trash collector that will use its forelegs to grab space debris from orbit. Scientists are even studying the possibility of soft robots, with the ability to move sinuously across rocky surfaces. One European Space Agency experiment focuses on an intuitive human-robot interface designed to solve even complex manipulation tasks. The Subfis Justin project is testing the possibilities of managing significant communication lags while commanding a robot to carry out dexterous work. German astronaut and geophysicist Alexander Gerst is excited by its potential.
Subfis Justin is a fantastic experiment because it takes human-robotic interaction up to a new level. We have a test here of a robotic system that is controlled by an astronaut in a spacecraft, in a space station in this case, and the robot is actually located on the surface of a planet. Well, in this case it's a test planet, it's Earth, right? Later on this could be Mars, it could be the Moon. All right, I'm coming a bit closer to the SB1. The scenario is as we are the crew on orbit around Mars, and we send a rover down there as the first scout to see how the conditions are like, whether it's safe, what the atmospheric parameters are. And so we command that rover, but the difference to how rovers were commanded in the past is that this rover actually knows to navigate by himself. So I don't have to tell him every millimeter to move in which direction or what to do exactly, but I just give him high-level commands like check out this solar panel or pick up this rock, and he will actually do that.
It's not just space where it's useful to have a robot to handle hazardous conditions. Animal is the world's first autonomous offshore robot. Equipped with a customized sensor head, the four-legged robot autonomously performs various inspection tasks on an offshore converter platform in the North Sea. The 320 kilovolt converter station has a 960 megawatts power transmission capacity, making it the world's most powerful installation of its kind. It can power more than 1 million households with clean energy. Animal helps to reduce the risk of disruptions and ensures the security of the electricity supply. The robot monitors machine operations, transmits sensory readings, and detects thermal hotspots and oil or water leakages. At any time, Animal can be remotely operated from an onshore control center to provide real-time information through the robot's onboard visual and thermal cameras, microphones, and gas detection sensors. Anybiotics, the company that created Animal, has the motto, "Let robots go anywhere." The four-legged robot has also undertaken an inspection of Zurich's sewerage canals, a labyrinth of drains and tunnels beneath the Swiss financial center. NASA's Puffer robot traverses difficult terrain using just 2 wheels. Flattened like cards, a number of microbots can be stored in a larger, four-wheeled robot and deployed when it's necessary to explore smaller spaces. Scientists plan to try them in dangerous places like volcanoes. As well as saving us from danger, robots are partnering with humans to take over the grunt work in some industries. At a Barcelona plant operated by the automotive giant SEAT, 8 autonomous robots can transport more than 2,000 parts per day. The robots communicate with their surroundings and regulate traffic by controlling the traffic lights. Known as an automotive guided vehicle, or AGV, these robots use the latest technologies in navigation recognition, 4G connection, and induction electric battery charging. But robots are just one part of the intelligent workplace. Samsung is using 5G connectivity to create dynamic networks that will transform the factories of the future. In a 5G-enabled smart factory, real-time communication among millions of sensors, devices, and systems will have the capacity to improve environmental safety and quality control. In Samsung's own factories, advanced technologies are improving daily operations, ranging from storage to manufacturing, transport, packaging, and shipment. This is possible by combining 5G networks with artificial intelligence, robotics, the Internet of Things, and mixed reality. When these technologies work together, they allow more intensive monitoring of products and manufacturing equipment, reducing the likelihood of defects. Robots can do the heavy lifting, working non-stop and at a steady speed that can't be matched by human endurance.
From human to robot, back to human again. The combination of a human with a robot overcomes the many limitations of a human being.
Automotive manufacturers have been swift to perceive the benefits of robotic strength. Hyundai has developed a new vest exoskeleton, or VEX, a wearable robot created to assist workers who spend long hours working in overhead environments. VEX enhances productivity and reduces fatigue by imitating the movement of human joints to boost load support and mobility. The wearable vest functions by combining multiple pivot points with multi-link muscular assistance, eliminating the need for a battery. At 2.5 kilograms, VEX weighs 40% less than competing products and is worn like a backpack. The concept of an exoskeleton comes from the tough external shells of animals, such as beetles and crabs, where a strong covering protects the body underneath. Some of the earliest human-designed exoskeletons were created for the military to increase soldiers' endurance. Today, tests are underway to see if it's possible to incorporate robotic technology into items such as clothing and footwear. At Nissan, line workers now wear a robotic exoskeleton that supports their legs, shoulders, and back, reducing the stresses normally placed on their bodies by up to 60%.
We are here in Nissan Barcelona, where we assemble the parts of the cars. There are some workstations where the operator needs to work with hands over head position, so this can make a little bit of stress of their muscles, and we are in search of some solutions to improve this condition.
In Spain, we have the Catalan Automotive Cluster, which is composed by a group of companies working together to improve the current conditions of the industry. They had a project to introduce the exoskeletons in the automotive industry, and we saw the chance to gather with them to collaborate. The exoskeletons help us to reduce the muscular efforts during certain operations. This results in less fatigue for the operator.
The first time I put on the exoskeleton, it was a strange sensation, but as I carried on working, it felt more and more practical to have my arms supported. There are various models, but I found one that was the most practical and, in the end, the most comfortable to work with.
After the trials, we find that with the use of the device, we can reduce up to 60% of muscular effort. In Nissan, we have a lot of new technologies that are used in our cars, so we want to also use new technologies for our employees. We have been trying these new technologies with a very good results.
As the partnership between robots and humans gathers pace, there's no limit to what can be achieved. Matching human ingenuity with the speed, power, and strength of machines will transform our lives in ways we can only imagine. In 1903, when the Wright brothers flew their flyer at Kitty Hawk, North Carolina, they could never have imagined the ways powered flight would transform the world. More than a century later, the Kitty Hawk Aeronautical Company, named in honor of the Wright brothers, is working on its own transformative technology. Kitty Hawk is one of the pioneers of all-electric vertical takeoff and landing aircraft, also known as eVTOL. Its latest concept is Heaviside, a single passenger plane with a range of 160 kilometers from just one electric charge. Heaviside is 100 times quieter than a helicopter, flying at a sound level of just 35 decibels, a level that is barely discernible to the human ear. With the ability to take off or land in a 100 square meter area that does not need to be paved, the aircraft has many potential applications. As cities become more congested, planners are looking at options such as flying taxis to get people off the roads. Urban aviation has the potential to put everyone in the pilot's seat.
My only dream from my childhood, I remember, was when I could fly, and it was such an amazing feeling that from that point on I just felt it has to be real.
Kitty Hawk's flyer prototype has a control interface so simple that would-be pilots only need an hour's tuition before they can fly it.
Very few of us have the privilege of flying, but now, in less than an hour, you can learn how to fly.
I think everybody on Earth, they dream of flying, especially as a kid. You look up in the sky and you see a bird, or you even have dreams at night where you just start flying. And now with Flyer, we're gonna be able to walk out to that dock today, get inside of it, and start flying. I feel completely prepared to get into Flyer and take off. We did the training yesterday, so we did the simulator training, and then we did the strap down where we turned on the vehicle and kind of revved it up, and it was tied down to the ground. I've felt the power of Flyer, and now to take the straps off and just start flying, it's a kid's dream come true. It's a complete breakthrough in aviation, to have something so simple, so intuitive, that someone like me can just get in and enjoy the freedom and the joy of flight.
That was incredible. It's like part of your body. Yes.
When it comes to urban mobility solutions, the biggest dream of all is the flying car. Having the option to switch between driving and flying has been part of our vision for the future since flight began. Aeromobile 5.0 is a Slovakian concept 4-seat flying car designed for door-to-door flying. When traffic is light, you can stay on the road. If it looks like you'll hit congestion, the onboard computer recognizes the route and sends you to a heliport, where you can launch into flight mode. Powered by an electric motor, the Aeromobile has wings that pivot backwards when the vehicle is in its driving configuration. It has a range of 700 kilometers and is designed to be flown in any weather conditions. If it's able to secure the necessary certifications and permits, the company plans to launch the 5.0 by 2030. So it might not be long before we see cars taking to the skies. Japanese company SkyDrive has a clear vision for how it sees flying cars fitting into our lives.
この先渋滞中、飛行モードを推奨します。飛行可能エリアに入りました。
東京のオフィスまで。
かしこまりました。候補が2カ所あります。
外部ノイズをキャンセル。
かしこまりました。旋回してください。
了解。
SkyDrive sees a future where flying cars are as common as land-based ones.
9時に間に合う。
5分前に到着予定です。
ギリギリだな。
SkyDrive is a Japanese tech startup that's designing another electric flying car. Japan is getting serious about being at the forefront of the flying car revolution. The country has set up a special council that brings commercial operators together with government regulators to work out the practical details of getting flying cars safely airborne. SkyDrive came from a group known as Cartivator, an association of engineers from established brands like Toyota, who worked on speculative designs in their spare time. Now Toyota is a SkyDrive investor, along with NEC and Fujitsu, and a number of Toyota executives have been brought on board as advisors. Thanks to the car company's support, SkyDrive is able to use the 10,000 square meter development base at Toyota City. That includes an indoor flight test facility, one of the largest in Japan. The company is also developing cargo drones with the ability to transport heavy goods and equipment to hard-to-reach places. The global market for flying cars is expected to be worth billions of dollars by 2040. SkyDrive is determined to be one of the industry's main players, and a recent successful manned flight shows it's on the right flight path. Rideshare company Uber is expanding its horizons from the ground to the air. To overcome the gridlock of city traffic, Uber wants its passengers to consider an electric vertical takeoff and landing aircraft as a transport option. By taking advantage of space above the skyscrapers, urban aircraft will reduce congestion and make cities feel more open and accessible. Uber pictures aerial ride-sharing as a way of providing a flight option across a city's busiest areas. The plan is to have customers check in at custom-built skyports located strategically around the city and hitch a ride in an autonomous aerial vehicle which would swiftly take them to the closest skyport of their destination. If necessary, the passenger would transfer to ground-based transport for the final stage of their journey. Uber's Elevate network includes partnerships with 8 of the world's most innovative aircraft manufacturers. They are each developing concepts for eVTOL aircraft built specifically for ride-sharing. Uber Air would be powered by Elevate Cloud Services, a suite of software with the ability to manage dense operations of unmanned low-altitude air traffic. The company is currently using its Uber Eats urban drone delivery service to test its air traffic management system. The top names in architecture, design and engineering are currently working on skyport concepts. It's a big task, as the buildings need to be capable of handling up to 1,000 landings an hour. Boeing is one of Uber's aircraft partners, and its latest autonomous passenger air vehicle has been undergoing rigorous testing. A check of the electric aircraft's autonomous functions and ground control systems saw it pass with flying colours, so it might not be long before it arrives at a skyport near you. The skies of the future will be teeming with drones and autonomous air taxis, as well as airliners. Aircraft manufacturer Airbus is developing an air traffic management system that aims to support the rise in unmanned aerial vehicles needing clear flight paths. The purpose of Airbus UTM, or Unmanned Traffic Management, is to identify the most efficient airspace structures for new technologies. The huge projected increase in small aerial vehicles travelling around cities makes it essential to create a system that enables all autonomous aircraft to communicate their positions with each other, as well as with an overarching traffic control.
The first step to achieving clarity in what are the standards and regulations for autonomous systems is that we need to get everybody together and sharing and open and on the same page. We need collaboration across the industry because this problem is bigger than any one company.
The entire aviation industry focuses around taking small steps first, which is very important. By getting small applications in place, we make valuable learnings, we gain a lot of information, we gain feedback, we gain economic information and viability, and all of that will boil together to produce an even better next iteration as we scale up the services, have more aircraft, and have them do more complicated things.
So it's a really exciting time for the industry. It's really just kicking off. We've done a lot of the R&D, and right now is when real UTM services are starting to be implemented.
The system we put in place today and over the next few years will be the system that's in place for decades to come, and it will affect the next generation of people using the air traffic control system.
As part of its digital transformation, Airbus has invested in touchscreen options for pilots of its A350 aircraft. When combined with the electronic flight bag, they provide easily accessible displays that bring up vital information with just the touch of a finger.
Welcome in the cockpit of the A350 XWE, which happens to be the best cockpit in the sky. The core of this cockpit is made by 6 large, identical displays, which have been developed by Thales. These screens allow to display the right information for the pilot to fly, navigate, communicate, manage the system, as well as with the EFB to manage the mission. This cockpit is the one of our MSN 373 to be delivered to China Eastern. For each pilot, the electronic flight bag is made of an airline laptop racked in a docking station next to the pilot seat. The display can be performed on the cockpit outer screens or something which is unique to the A350 when a pilot selected OIS on center on the lower center display. The control of the electronic flight bag can be obtained via the tablet integrated keyboard or via the trackball controlling a cursor via the Keyboard Cursor Control Unit, or KCCU. The new development made by our supplier, Thales, makes their screens capable to be touch screens. This is a new way allowing interactivity with the electronic flight bag applications, and for the time being only on the EFB applications.
But perhaps this technology is just a stepping stone to something even more advanced. Airbus has spent the past 2 years successfully testing autonomous taxi, takeoff and landing of a commercial airliner, a world first in aviation. This has been achieved through fully automatic vision-based flight tests using onboard image recognition technology. More than 500 test flights have been flown, with 450 of them dedicated to gathering raw data to support and fine-tune algorithms. A series of 6 flights conducted 5 takeoffs and landings per run to test the aircraft's autonomous flight capabilities. In Wyoming, USA, scientists are working to improve weather forecasts.
Mike from Monarch. We're testing a GNSS-RO sensor on board the Atmospheric Research Laboratory from the University of Wyoming. Back there, Brian and Paul from Night Crew Labs, just making sure that everything works. What our flight plan is we basically go up as high as we can on the aircraft. Then we maintain altitude, continue a straight and level flight for about 280 nautical miles. We make a U-turn and we come back. The aircraft is collecting multiple channels of atmospheric data, and we're looking at humidity data. We have a vertical LiDAR profiler. We have a cloud camera that's taking pictures of water vapor particles as well as icing droplets.
The sensor payload tested on the mission has the potential to improve the choices we make around weather-related events by adding truth data to forecast models and increasing accuracy.
So how's flying a plane?
That was such a unique experience. That was one of the coolest things I've ever done. God.
One of the things that's so amazing about this trip is that my whole life I've wanted to work in aviation and I've wanted to work on flying laboratories. The view is beautiful outside, but you have a lot of work to do, and you're getting in the console, making sure that all the parameters are coming back correctly, and it's really a thrill. Like I really enjoy it. And yes, we have a lot of flying hours to do. Hopefully I enjoy it by the end, but it's just gorgeous scenery and amazing science. So I am really happy.
Flying be like in the future? How will automation and customized options change our traveling experience? Manufacturers such as Airbus are investigating ways new technologies can be integrated into existing design. One possibility is cabins that automatically reconfigure to accommodate the number of people on a flight. Instead of overhead bins, passengers place their hand luggage in a separate storage area to be retrieved at the push of a button. The ecological self-cleaning seats will morph to suit the shape of the person sitting in them, while a floating touchscreen provides instant access to entertainment and assistance. The engineers who designed this fantasy flight envisage an aircraft that's ultra-long with slim wings, semi-embedded engines, a U-shaped tail, and a lightweight, intelligent body. This design will improve the flight's eco-efficiency, resulting in lower fuel burn, a significant cut in emissions, less noise, and greater comfort. Those planning for the future believe that passengers will expect seamless access to a wide range of technology and applications. Flexibility will be key, so we can enjoy many different experiences on board. Hologram pop-ups take you to whatever social scene you want to experience, from conferencing to virtual meetups. The airliner of the future will not just be a mode of transportation. It will include wellness options that make travel energizing and exciting. Walls that become transparent at the touch of a button, making you feel as if you're floating above the clouds. Holographic projections of virtual decors allowing travelers to transform their private cabin into an office, bedroom, or Zen garden. The aircraft's bionic structure mimics the efficiency of bird bone, which is optimized to provide strength where needed. This allows for an intelligent cabin wall membrane, which controls air temperature and the level of transparency. The cabin's integrated neural network creates an intelligent interface between passenger and plane and can identify and respond to passenger needs. This includes the opportunity to experience vitamin and antioxidant-enriched air, mood lighting, aromatherapy, and acupuncture treatments, all while taking in the panoramic view. By offering different experiences within each zone, airlines would be able to achieve price differentials and give more people access to the benefits of air travel with minimal environmental impact. While some of these concepts may seem beyond the realm of possibility, the fast pace of technological development means they might just be closer than you think. With autonomous airliners on the horizon and short-hop electric sky taxis waiting in the wings, it won't be long before our skies and our modes of transportation look very different. One option for our aviation future is hypersonic airliners, a concept Boeing has been working on for some time. It could see us crossing an ocean like the Atlantic in under 2 hours.
It obviously looks quite a bit different than what you would consider a normal airplane to be. One of the key differences is what it's made out of. When you're traveling that fast, friction causes the surface to become very, very hot, over 1,000 degrees, sometimes well over 1,000 degrees, depending on how fast you're going. So you can't make it out of aluminum. You have to make it out of more exotic materials. For example, at about 1,000 degrees, you can use titanium. Beyond that, you can use nickel-based alloys, something called Inconel, up to about 1,500 degrees. Beyond that, you have to go to ceramic materials.
At this stage, hypersonic passenger flight is more conceptual than realistic. Airbus sees potential in electric-powered airliners as it searches for ways to fulfill its mission to increase environmental efficiencies. EFAN-X is a complex hybrid electric flight demonstrator that has had one of its 4 engines replaced with a 2-megawatt electric motor. In partnership with engine manufacturer Rolls-Royce, the project tested the possibilities and limitations of a serial hybrid electric propulsion system in a demonstrator aircraft, the first of its kind in the world. More than 30 projects are currently working on hybrid electric power for airliners, and it's hoped the technology could become commercially available in just over a decade, leading to lower emissions and reduced fuel bills. But aviation in the future is not just about repurposing today's technology. Some options might see us reaching even higher than sky.
The very first thing that we did as a company when we started out was we talked to our customers about their expectations for what they wanted when they went to space. And it was those expectations around the rocket ride, the weightlessness, the view of the Earth from space, and the reception of their astronaut wings upon the conclusion of the journey that were the key drivers behind our entire design process.
So, where will you fly tomorrow? Virgin Galactic is moving closer to its goal of providing suborbital space flights for tourists. The Richard Branson-founded company has released a conceptualization of what the cabin of its first Spaceship Two vehicle, VSS Unity, will look like. Space enthusiasts can download a free augmented reality mobile app to experience it for themselves. The cabin has been created to integrate seamlessly with every other aspect of the Virgin Galactic astronaut journey, as well as being a design centerpiece in its own right. Each passenger is issued an individually sized reclining seat for G-force management and float zone volume. Automated mood lighting harmonizes with each flight phase. Personal seatback screens connect astronauts to live flight data, while the cabin architecture supports effortless movement in weightlessness. Soft surfaces and elements become intuitive hand and footholds. And most importantly, there are 12 cabin windows through which astronauts can gaze down at Earth. The windows have soft, extended edges, allowing astronauts to perfectly position themselves for 360 degrees of awe-inspiring views. Chief Astronaut Instructor Beth Moses has had the opportunity to trial this unique experience.
My name is Beth Moses, and I'm the Chief Astronaut Instructor and a flown astronaut at Virgin Galactic. I was the first person to fly in the customer cabin of Spaceship Two as an engineer and an instructor testing the cabin. And that flight showed that the cabin was ready for human occupancy. I flew in a prototype cabin with research payloads, tested a lot of things. It tested a few ways to get in and out of the seat. It tested ways to improve the seat interfaces. It tested translation aids, handling aids, how you move about the cabin. Very fundamentally, it looked at how the cabin moves about you when you are floating and weightless. What aspects of the experience stand out, perhaps in ways that we didn't anticipate before a human could go calibrate that. So now I've rolled that all into training and into the cabin design so that it is perfectly tuned, elegant, easy, safe, wonderful. It was already freaking remarkable, and now it's even more so for all of our future customers. So the moment where we strapped in and the hatch was closed and the wheels started to roll sticks with me as a moment of sort of personal gravitas, like I am about to do the most important job of my life, and I am going to do it well. The rocket motor is not exceptionally loud. You are under 3G, you are rocketing into space. It is the rocket ride of your life. And then the rocket motor cut off. You can see the Earth outside all the windows. It is super, super bright, very high definition. It just engulfed me. Space is deep, deep, deep black, and it looks endless. And probably the next standout moment, I did the first half of my test, and then I purposely joined the pilots near the cockpit for apogee. And that's probably the standout moment of my life. Floating, free, in the ship, and the ship came to a stop above Earth, and it felt endless. The cabin interior supports savoring the view of Earth from space in every way possible. It both facilitates your movement about the cabin so you can get to any window or next to any person that you'd like to, while simultaneously not distracting you from the view that you're looking at. The cabin interior will be successful when the space flight and the view of Earth from space is the star of the show, and the cabin is almost an invisible but perfect supporting act.
But it's not cheap to take a ride on the VSS Unity. For $250,000, you get a 90-minute flight that takes you high enough to experience weightlessness and see the Earth from space. By surpassing an altitude of 80 kilometers, Virgin Galactic space tourists will also receive official astronaut status. Amazon's Jeff Bezos is another entrepreneur who has his sights set on space. The billionaire founded commercial spaceflight company Blue Origin in 2000, with the aim of making access to space cheaper and more reliable through reusable launch vehicles. Blue Origin envisages a future where millions of people live and work in space, tapping its unlimited resources and energy. Its rockets transport payloads for organizations such as NASA, who have used the launches to further research for their upcoming moon mission. At a cost of just $8,000 a payload, the company has even flown experiments for school students. A second-grade class in Indiana was able to demonstrate that fireflies can light up in zero gravity. Blue Origin's New Glenn orbital vehicle will take tourists into space, where they will experience weightlessness and new views of our planet, just like the Virgin Galactic astronauts. The cost is expected to be about the same. Blue Origin was recently awarded a NASA contract to develop an integrated human landing system as part of the Artemis program to return humans to the moon. The third big player in the commercial space industry is SpaceX, the company founded by Tesla's Elon Musk in 2002. Its original aim was to reduce the cost of space transportation to enable colonization of Mars. The company has since become the first private operator to successfully launch, orbit, and recover a spacecraft, and the first to send a spacecraft to the International Space Station. SpaceX's latest innovation is an interplanetary transport system known as Starship 4, to be used for crewed missions to Mars. Expected to be completed by the early 2020s, Starship will be the biggest rocket ever made. The system will comprise a fully reusable, two-stage-to-orbit, super heavy-lift launch vehicle, which requires considerable testing due to its innovative design. The heavy launch vehicle is just required for the initial launch, as only Earth has the deep gravity well that requires such a powerful booster rocket. Once the vehicles escape Earth's gravitational force, Super Heavy detaches from Starship, leaving the lighter spacecraft in parking orbit. The booster then flies itself back to Earth, landing on its original launch mount, ready to be prepared for its next expedition. When you put a human being in a spacesuit, sometimes the impossible is possible. Since 1965, NASA has conducted hundreds of EVAs, short for extravehicular activity.
So when I think of EVA, I think of the symbolism of a fellow human being existing for even just a short period of time, alone and separated from nearly everything else. And I think of that symbol of that single person representing our species and representing our voyage of exploration.
Before exploration can take place, before a human being can step outside the spacecraft, another mission must be accomplished: the creation of the spacesuit. Throughout the history of EVA, NASA has sought to build the best spacesuit and tools to match the job required for the mission. For its suit engineers, this means designing, testing, and redesigning to get it right. During the Gemini program, designers were faced with the challenge to create the first US spacesuits. Suits that would allow the astronauts to work outside the spacecraft in low Earth orbit. Building on that experience, new suits were developed for the Apollo missions. This time, astronauts needed to walk on the moon while carrying their own life support on their backs. With planetary surface exploration as the objective, the suit had to bend and move to allow tool use and protect the human. During the shuttle years, NASA redefined what could be done with the EVA suits and tools. The same shuttle spacesuit is on the space station today. It allows astronauts to maintain and repair their home in space. But what about future missions? What kind of suit will we need for walking on an interplanetary surface, floating in microgravity, or both? NASA is already investigating the next generation of spacesuits, working on a range of prototypes to prepare astronauts for the journeys ahead. The Z2 is one of those prototypes. Its sleek design looks different from any other spacesuit NASA previously built.
We were able to take some artistic license on this prototype spacesuit and have some fun with it and engage folks out around the country for what they would like to see in a spacesuit. We worked with Philadelphia University to do the initial layouts of the suit, and then we have some in-house fashion designers that also help build our spacesuits, and they were able to bring their experiences to it and evolve that cover layer to make it even better than what we started.
The Z2 isn't just fashion-forward on the outside. It's also technologically advanced on the inside.
To be a planetary spacesuit, some of the special features on the Z2 are boots specifically designed for walking and for keeping your foot integrated into the boot well, like a good hiking boot. It also has a lot of lower torso mobility that allows you to walk naturally so that you can go uphill, downhill, into craters, pick up a rock, as a geologist would want to do on a planetary surface.
Like any prototype, NASA hopes to learn a lot from the Z2 as it continues to improve and develop spacesuits.
Prototypes are really important for spacesuit development because you can only do so much in the modeling and analysis world. You really don't know how well the suit works until you integrate it with a person. You get the feedback that a person can give you. You have them walk around, you have them try different tasks. That's how we really know that we've done a good job designing a spacesuit.
Another suit in the works is the Prototype Exploration Suit, or PXS. This suit can be used for EVAs in microgravity, or it can be further modified for walking on planets. As with all future spacesuits, NASA is wanting to see better mobility, better visibility, and better control and communication.
So one of my main responsibilities on this spacesuit is the suit control assembly, and that's the box that sits right here on the front of the suit. And it allows the crew member to control their life support components, such as their cooling and their pressure, and it also controls a lot of the electronics, such as the radio and the volume, and they can see some of the data that's coming back and forth from the suit computer to that display. So one of the great things about this job is that after designing the box, I'm able to get into the suit, since it's one of the smaller sizes, and we can actually see what the limitations are with my own hands and eyes, and not just hear that secondhand from another test subject that would be looking at the same data. And then to take that back and then to go build the next prototype and incorporate the changes that need to be made so that it works better the next time.
It's not just spacesuits that are key to a successful EVA. Astronaut training is also vital, especially when the mission is difficult. European Space Agency astronaut Luca Parmitano recently undertook a spacewalk at the International Space Station to repair the alpha-magnetic spectrometer. The AMS-02 is a particle physics experiment mounted to the outside of the space station. 3 of its 4 cooling pumps needed replacing.
It's a combination of things that makes this EVA so challenging. You have certainly an access problem. AMS is in a remote area without handles or locations to hold on to because it was not made to be repaired EVA.
0 and liftoff. AMS was carried to the space station on the final flight of Space Shuttle Endeavour and installed using the shuttle's robotic arm. As the most sophisticated particle detector ever sent into space, AMS allows scientists to find dark matter. To date, it has detected over 100 billion cosmic particles, greatly enhancing our knowledge of the universe. When the decision was made to extend the instrument's life, a series of specialized tools and novel spacewalk techniques had to be developed. At the Johnson Space Center in Houston, experienced spacewalker Luca Parmitano played a key role in this process.
I've been lucky enough to have been part of the development team from the beginning, initially just as a consultant and then actually getting closer to the team in using me as a test subject for some of the tools. They've been incredibly receptive to our suggestions and responding to our ideas. It's been exciting.
Working inside a spacesuit in microgravity poses many challenges. Luca and his NASA colleague Andrew Morgan trained on specialized equipment to recreate working conditions in orbit, such as the Argos system, which effectively removes gravitational force to create a simulated EVA environment. Numerous underwater sessions in NASA's Neutral Buoyancy Lab gave Luca and Andrew a working knowledge of the space station's exterior, rehearsing fully suited operations on a mock-up of AMS.
We're going to perform what could be considered open heart surgery on this amazing experiment. We're going to cut tubes and then fuse them with other tubes that we're going to bring from Earth and install a completely new pump to help the refrigeration work, keeping the magnet cold so that the alpha magnetic spectrometer can work.
Drawing on their extensive training and experience, Luca and Andrew have since successfully undertaken a challenging series of spacewalks to restore the alpha magnetic spectrometer. Their mission included cutting and splicing 8 cooling tubes, connecting them to the new system, and reconnecting power and data cables. It was the first time that astronauts had cut and reconnected cooling lines in orbit. They also had to identify and repair a leaky feeder tube. As the astronauts worked on their tasks, they were closely watched by Mission Control in Houston. When undertaking strenuous work, they used more oxygen, so their spacesuits were carefully monitored to see how they were performing. At 5 hours and 2 minutes into their third spacewalk, Luca broke the record for accumulated time outside the space station by a European astronaut. It was the 227th spacewalk for the International Space Station. Thanks to their efforts, the AMS has now been fully restored, allowing it to explore our universe for many more years to come. 50 years after putting the first man on the moon, NASA is planning to return.
We have a bold vision to go, and we do so knowing that space exploration has improved the human condition in countless ways. And it is the partnerships over the last 50 years that have ensured a steady progress in the science, technology, exploration, and discovery for the benefit of all. With America's new directive to put humans on the moon in 2024, NASA is leading the development of exploration capabilities, and we are building a coalition of nations that can help us get to the moon quickly and sustainably together.
With the help of partners such as other space agencies and private space companies, NASA is working to an ambitious timeline. Next-generation space technology is being used to build advanced spacecraft to take crew to the moon and ultimately to Mars.
Accelerating the timeline means a lot more focus, means a lot more dedication to the task, and we're up for it.
One of the key mission features is the development of the Gateway, a moon-orbiting platform that will serve as a waypoint for human capsules.
Gateway is a great step towards the future of the human being. It's a great pleasure to collaborate with NASA in that endeavor.
Gateway can be moved between orbits and will balance between the Earth and Moon's gravity. But the technology is so advanced, it requires the best scientific minds from all over the world to contribute.
NASA is one of our major cooperation partners in space exploration.
By going together to the moon, forward to the moon, whatever the time span is, the faster the better. That's something I really like.
Scientists hope the lessons learned will enable them to develop a successful mission to Mars. Between 1968 and 1972, NASA launched 9 human missions to the moon, 6 of which successfully touched down, allowing men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of both creating a long-term human presence on the Moon and preparing for a human mission to Mars. To reach the Moon, astronauts will fly in Orion, a spacecraft built in 3 parts. The crew module can house up to 4 astronauts who will live and work throughout the flight. The service module contains the life support systems for the crew and its own engine and fuel reserves. And there's a launch abort system with engines capable of pulling the crew module to safety at launch should anything go wrong. The world's most powerful rocket, when fully fueled, Orion weighs over 6 million pounds. 5.2 million of that is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, projecting the crew upwards. 2 minutes after ignition, the rocket boosters are spent and released. At 8 minutes, the 4th stage is depleted and separated. Approaching the Moon, we see a difference between the Artemis and Apollo missions. Artemis will use a revolutionary approach, pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners, including Gateway, the dedicated lunar station in orbit around the Moon. Here at this station, the astronauts can pre-stage a robust lunar lander and establish a strong communications relay. When that's complete, selected astronauts transfer to the lander and descend to the surface. They use the same lander to leave the Moon and head back to the Gateway, where they return to Orion, firing their engines once to break out of the halo orbit, and once again to sling the spacecraft around the Moon. They head back to Earth. Nearing the end of this journey, the service module is released and the crew module is oriented heat shield first. The deployed parachutes decelerating the craft to just 20 miles per hour for splashdown.
10, 9, 8.
The recent launch of the Mars 2020 Perseverance rover highlights the next chapter of Artemis, the mission to Mars.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
Oh man, that's the noise.
It might not be long before we join robots on Mars and experience the next frontier of human endeavor.
Can you feel it inside?
So, where will you fly tomorrow? The greatest technological challenge of our time is the fight to protect our planet from the effects of global heating. Most scientists agree that a reliance on fossil fuels has changed the Earth's climate for the worse, and as temperatures rise, so do the threats to human existence. One of the biggest problems is the effect melting polar ice is having on our oceans. As the ice melts, sea levels rise, threatening low-lying islands and causing damaging floods. Sea levels are currently rising at a rate of 3.6 centimeters a decade, and every centimeter rise puts another 3 million people at risk of annual coastal flooding. So the European Space Agency is looking to the heavens for help. The ESA has launched the Copernicus Sentinel-6 satellite to provide accurate, reliable long-term observations of sea level rise. After a former NASA scientist, the Sentinel-6 Michael Freilich is the first of 2 satellites to be launched. Sentinel-6B is scheduled to start its mission in 5 years' time.
Sea level is a very direct symptom of global warming, so it's very important to measure it accurately And sea level increase is related to the melting of ice of the poles. It's also related to the accumulation of heat in the oceans. So these two elements together make the product of Sentinel-6 very relevant for the society.
As well as mapping the height of the sea surface, the satellite's data can also be used to measure waves. This will be particularly useful for understanding storm surges, a type of flooding that can overcome coastal defenses and cause catastrophic damage. The Sentinel-6 satellites join a family of sentinels in the sky, all focused on our planet's seas.
Europe today really has a leadership in Earth observation, and it has the largest Earth observation program in the world with all the satellites which we are developing. There are 3 series. There's the Earth Explorers, which are the science missions, the Copernicus missions, the Sentinels, and the meteorological missions, and the totality of those missions, together with national missions in the various member states of ESA, are today the biggest Earth observation capacity in the world.
More than 600 million people live on land that is less than 10 meters above sea level. So it's vital that we find solutions to the problem of increasing ocean levels. One of the key defenses humanity has against global heating is the development of sustainable energy sources. The fossil fuels we currently rely on pump carbon dioxide into the atmosphere, accelerating climate change and contributing to extreme weather events. Many scientists and futurists believe that the development of sustainable power options will fuel a new industrial revolution. So what are some of the alternative energy sources in the pipeline? Hydrogen is a low-emission fuel that's catching on around the world, especially when it's sourced from renewable options. Just like gas, it's possible to set up hydrogen tanks to use for car refueling. The difference is that hydrogen power can be produced by using solar or wind power, rather than fossil fuels. And hydrogen's not the only option for car makers looking for sustainable fuels. Water management company Aquilia has teamed up with SEAT to turn wastewater into fuel. This solves 2 environmental challenges: conserving precious water resources and finding alternative energies that reduce pollution. The production and consumption of this new biofuel reduces CO2 emissions by 80% compared to petrol-powered vehicles. This renewable biofuel can be used to power compressed natural gas cars. But how do we turn wastewater into biomethane? In the treatment plants, a physical decanting process in tanks separates the water from the sludge, which is then converted into gas following a fermentation treatment. After a process of purification and enrichment, the biogas is ready to be used as fuel. A car can drive nearly 5 million kilometers with the biofuel obtained from the water used by 50,000 inhabitants and treated in a year in a mid-sized treatment plant. In other words, it could circle the globe 100 times and make 6 return trips to the moon. Every day, a medium-sized plant can treat around 10,000 cubic meters of water and generate 1,000 cubic meters of biomethane, enough for more than 150 vehicles to drive 100 kilometers per day. Another renewable energy source is transforming our world in surprising ways. While we are familiar with the use of solar power in homes and industry, you may not be aware that even aircraft are harnessing the rays of the sun. To test the potential of solar aviation, the revolutionary Solar Impulse aircraft circumnavigated the globe, with adventurers André Borschberg and Bertrand Piccard at the controls. The record flight would not have been possible without the help of a mission control based in Monaco.
really, during the flights, we are monitoring the flight. We will help the pilot. We will give him updates. Oh, here maybe the wind changed, so we suggest you go here, you go here. In the plane, we have only one pilot, and the second pilot, or the first officer, or the co-pilot, is this area here.
Our partners, they don't come from the world of aviation. They come from the world of industry. And the technologies they provide to us are the ones they put on the market.
The Solar Impulse is currently being converted into an unmanned aircraft for US startup Skydweller Aero. It demonstrates that solar power has the capacity to meet many of our future energy needs, as we search for clean alternatives that won't cost the Earth. When it comes to making our everyday more sustainable, there are many technologies in development that will reduce our carbon footprint in unexpected ways. Spanish auto manufacturer SEAT has created a 3D printing lab that enables it to create parts without molds, with no design limitations.
80% of the pieces we make are development prototype parts, but more and more we're making tools that can be used for the vehicle assembly process. We're also creating pieces for different uses. We've been making face masks for people who are uncomfortable with surgical masks, or even hands-free door opener accessories that can be used with your forearm.
3D printing can provide parts up to 10 times faster than other types of manufacture.
Our design and development colleagues benefit from the advantage of having parts immediately, because when they're working on a new model, they can have different versions very quickly and can make changes, if necessary, in the final version.
3D printing makes it possible to create parts on the spot, rather than shipping them across the world.
In the future, we want to use the technology to make both customized parts for clients as well as accessories.
In a different field, Japanese farmer Tadashi Fukuoka is using futuristic technology to protect his beloved tomato plants. Tadashi is still a hands-on farmer, but thanks to a sensor system developed by Bosch, he's able to access highly accurate data from the environment, such as temperature, humidity, and CO2. This alerts him instantly to infection risks and reduces the need for pesticides by up to 50%, a saving for both his wallet and the environment. The Plantech system was specially designed for Japanese farmers, as most farms in Japan are small, family-owned operations. Using technology to create personalized solutions is a concern in the fashion industry too. Designers are looking for ways they can connect with customers by providing them with unique products created in a sustainable way. Co-founder of Fashion for Good, William McDonough, is passionate about creating products that benefit people and the earth.
Fashion is by definition the making of things, and fashion as it transforms with culture is by definition innovation. So it's the making of things and innovation at its core.
Fashion for Good supporter Leslie Johnston is focused on identifying existing innovations that can be applied today.
Innovation is really important for transforming the global apparel industry, but in our view, it's not about creating more innovation, it's about taking the innovations that are out there, scaling them up and embedding them in the industry. There's no shortage of incredible ideas and new ways of doing things, but where there is a shortage is how you get those to scale. And that's really the core of what Fashion for Good is doing, is trying to find, support, scale up, and embed those innovations in the supply chain so it could really transform the way that our clothes are made.
The company is keen to get the fashion industry involved in a process that would see designers create an item of clothing that could be endlessly recycled, resulting in zero waste. McDonough sees fashion as the perfect fit for this framework.
Textile innovation is fantastic because it's a three-dimensional event. It's about weaving stories together as well as materials. Every thread is a thread of a story. Every story has threads. So textile innovation is stories of human production, it's science, it's culture, it's art, it's relationships of people to the planet, it's agriculture, it's technology. The textile is the fabric of life itself.
One of the benefits of space travel is the ability to view the Earth from a new perspective. Our globe has never looked more fragile than when seen at a distance. The launch of satellites that allow ultra-high resolution imagery and mapping is benefiting many fields of endeavour that help protect the planet. One of these is a project from Google that uses artificial intelligence to provide better warning for floods. Scientists feed information such as historical events, river level readings, terrain, and elevation into their models to generate maps and run simulations at each location. From this, they have created river flood forecasting models that can more accurately predict not only when and where a flood might occur, but the severity of the event as well. Google already issues alerts about natural disasters through the Google Public Alert program, but this initiative takes it a step further. The company has partnered with India's Central Water Commission to obtain the data needed to roll out early flood warnings, starting with the Patna region.
The response time is most crucial thing. Reducing the response time always plays very important and vital role in the whole disaster management framework. Advancement in technology would help us better in spreading this message faster.
Flood forecasting was a very exploratory project. The big technical question was, can we have enough information to try to do forecasting that would be accurate enough to make a difference? Starting with the basic needs for getting information about what's going on, where is it happening, what should I be doing?
As more people are killed by flooding in India than anywhere else in the world, using AI to develop more precise warnings will be a lifesaver. To develop an accurate flood forecast, scientists begin by collecting thousands of satellite images to build a digital model of the terrain. Based on these maps, they generate hundreds of thousands of simulations of how the river could possibly behave. They can then send those forecasts to individuals using search, maps, and Android notifications.
This is an example of an alert that we can produce. This alert is for Patna. This alert has over 90% accuracy.
The researchers have also found it vital to talk to people who have experienced severe floods to see what they find important. Eventually, the technology developed for Patna will be rolled out to other places around the world, with the aim to give people 3 to 4 days warning of floods coming to their area. It's the most popular food on the planet, the basis of world-famous dishes, and now its husk can be part of a car. We're talking about rice. As an innovative pilot project based on the circular economy and with the goal of reducing its carbon footprint, SEAT is researching the use of orezite as a substitute for plastic products. More than 700 million tons of rice is harvested each year. 20% of this is rice husks, some 140 million tons, which is usually thrown away. Now scientists have found a use for those husks by turning them into orezite, a product that can be mixed with other heat-stable thermoplastic compounds and molded. As well as car parts, there are many applications for recycled rice husks. They can be used to create furniture, buttons, clothes hangers, and cosmetic containers, products that are currently made using petroleum-based plastics. Orezite does not ignite easily and has a low moisture absorption. It also has a unique look and feel. Say it has trialled rice husks mixed with synthetic materials in parts of a car, such as the rear hatch, the double load floor of the boot, and the ceiling headliner. At first glance, they look exactly the same as car parts made with conventional technology, but they weigh much less. This lessens the weight of the car, reducing its carbon footprint. Innovations such as this are vital in redefining our transport options. When combined with battery technology, it will result in fewer emissions and more livable cities. But as we ride into the future, experts warn there is still much to be done.
The most important thing is that we have to decarbonize mobility, because we have not been making progress in this field. No? We are making progress in energy, we are making progress in buildings, we are making progress in the industries. In mobility we don't, and we need to do so. Now, we'll be talking about electrification and decarbonization of cars, but beyond that I would like to combine this with livable cities. No? So livable cities, people-centered cities, and better mobility is what I'm interested in.
One of Tesla's visions for better mobility involves a fully electric utility. The futuristic Cybertruck is a battery-powered light-duty vehicle that will have an estimated 400 to 800 kilometer range depending on the model. Tesla founder Elon Musk is also keen to develop an amphibious version of the truck. Designed specifically for dry land, Rinspeed and Harman's latest concept car showcases the connected, semi-autonomous vehicle at its most advanced. The Rinspeed Oasis is a maneuverable speedster with an integrated small garden plot behind the windshield. With its finger on the pulse of the social web, the Oasis works out its own route based on traffic conditions, while its slightly curved 5K windscreen display presents information as required. This next-gen car can think for itself, leaving its occupants plenty of time to focus on other things. Like the head-up display on an aircraft, the Oasis projects important information onto the windscreen by using holographic laser projection. Tired of driving? The steering wheel folds flat and turns into a keyboard or work surface. This turns the car into a self-driving office on wheels, complete with office productivity software and Skype video telephony with live translation. The personal assistant not only knows who's talking, but also the language they're speaking. Electric car users know the frustration of running out of battery. The Oasis automatically coordinates with a robot bearing a replacement battery. Simply swap over the power banks and you're back on the road. The compact car uses different sensors based on NXP technology to capture a 360-degree view of its surroundings with pinpoint precision. It will happily park itself and wait to be recalled by your phone. British company Virgin's concept of a better mobility involves a pod propelled at speeds of over 1,000 kilometers an hour via an underground tunnel. While other companies are working on similar technology, the Virgin Hyperloop is the first to successfully send passengers on a test trip. Virgin boasts that the Hyperloop will deliver airline speeds, the same G-forces as rail, and the ease of riding a metro. Instead of a timetable, pods will leave on command and won't need to stop at every station. Each pod can be configured to carry up to 28 passengers and light luggage. At the DevLoop site in Nevada, the Hyperloop has been run through more than 400 tests for aerodynamics and safety. The DevLoop test track is 500 meters long and 3.3 meters in diameter. The Hyperloop pod is able to reach high speeds because it is placed in a tunnel that acts as a pressurized tube. Once the tunnel is sealed, most of the air is sucked out to reduce resistance. The pod is then pulled forward by a chain of magnets placed along the tunnel, reaching transonic speeds of more than 1,000 kilometers an hour.
All right, team, please confirm you're ready.
Ready.
Ready. Prepare for launch in 5, 4, 3, 2, 1. Launch.
Virgin employees Josh Geigel and Sarah Lucian recently became the first people to travel in the Virgin Hyperloop. While some scientists doubt the technology will ever be commercially feasible, Virgin is pressing on with plans to build a $15 billion Texan Hyperloop. The biggest concerns include the difficulty of maintaining a vacuum in a tunnel hundreds of kilometers long. Some experts worry that earth tremors or other unforeseen disruptions could lead to a catastrophic accident. But Virgin's engineers are confident they can overcome these obstacles and are working hard to scale up their test models. It won't be long before we'll know whether our future involves transonic travel in a tube.
Baking a cake. But this was a kitchen like none I'd seen. Put a card in the slot and onto the screen pops a picture of just how your dish will look, plus all the ingredients you need to cook.
Automation was the ultimate dream for the mid-century homeowner. Thanks to perfectly designed kitchens with labor-saving gadgets, modernization promised consumers a life of ease. Frigidaire imagined a futuristic kitchen where the automatic oven baked the cake. 70 years on, the dream hasn't changed.
So we're going to start here, the front of my home. Here I have my LG Smart Door. Right next to it I have my LG Fresh Keeper for deliveries.
Consumer electronics companies are always looking for innovations. This might have been developed by the CIA.
This is called biometric authentication.
But if it has a real-world application, these corporations will find it.
And the key to getting inside is actually the veins in my palm.
The COVID-19 pandemic has focused attention on the home as a haven, and any tech that reduces person-to-person contact will be in demand.
There you go. I get a receipt screen, so I can go ahead and check and make sure that everything I ordered is here. Now, watch what happens when I close this door. I get the details of my next delivery.
As well as high-tech gadgets, we'll prioritize freshness and sustainability. How about combining them?
There's nothing quite like the satisfaction of growing and eating your own produce. Now, this is my indoor garden. It's one of the column-style appliances, kind of like the wine cellar here and the freezer here. Now, you can actually grow vegetables and herbs all year round from seed to table with very little hassle.
Our love of big screens hasn't waned, but the desire to have them dominating our living spaces has. Tomorrow's televisions are elegant and discreet, disappearing from view until required. Invisible, personally responsive technology merges into our lives, connecting us in every room of the house with time-saving innovations. The focus is on continuous improvement, as electronics companies battle it out to create the easiest and most intuitive solutions to automating household chores. The purpose is to free up our time for more enjoyable activities, in the same way electric washers once freed women from the drudgery of the washboard and wringer.
This interview can show you what's inside the fridge, but the new InstaView can actually recognize items as well. So let me show you what I'm talking about with this eggplant here. So I go ahead and I open the InstaView. I'm going to pull out the crisper, put the eggplant in the crisper, close the crisper, close the doors, and there we go, eggplant is added to crisper. Now I can see here that nice clear picture. If I go up here, I see that the eggplant was added to my food inventory. And this is going to keep track of things like expiration dates. Now if I go up here, I have recipes, so I can choose my ingredients, and I get recipes that contain those ingredients. So because this is an eggplant, I get things like ratatouille. Now let me show you what the menu looks like, what the recipes look like. I have a description, it'll read it to me if I want it to, and I have this button here that says preheat oven. Now this is one of the comforts of living in a totally connected home. If I hit preheat oven, my oven is going to automatically start to preheat at the correct setting and the correct temperature.
You might be surprised which items in our future homes will be connected. Once used just for grooming, the humble bathroom mirror might be transformed into a touchscreen. Multitask by shopping or checking in with social media while you wash and dress. How does it work? It all comes down to the Internet of Things, or IoT. IoT is an evolution of mobile, home, or embedded applications that can be connected to the Internet. As related devices connect with each other, they can become an intelligent system of systems. And when these intelligent devices and systems share data over the cloud and analyze it, they can transform our businesses, our lives, and our world in countless ways. The potential for our lives to be improved through greater connectivity is increased when the transformative power of robotics is added to the mix. In recent years, developers have made huge advances in their ability to control robot motion. With the help of advanced programming and precision engineering, robots are poised to take over the kitchen, if not the world. Imagine a robot selecting the ingredients from the pantry, preparing them for cooking, and then creating a meal. It's already happening. Personal robots like Samsung's Techie can follow you around the house like a butler. These robots are the early prototypes for products that will eventually integrate into our lives in ways we can only imagine. Techie uses autonomous navigation and AI technologies to provide services previously restricted to humans. In a world where it's sometimes safer to limit face-to-face contact, robots like Techie will become a vital member of the workforce. Robotic technology is also becoming more agile and intuitive. For those who have large perimeters to secure, robots such as the S5 security bot can perform monitoring services. Mixing autonomous vehicle technology and camera surveillance, these robots effectively identify and track down intruders. But not all robots are large and threatening. The Tarpia communication robot is more like a cute animatronic friend. Tarpia can alert you when your cooking is ready. Buttons and controls are minimized in favor of voice commands. Thanks to the Internet of Things, assistants such as Tarpia and Samsung's Barley will connect home appliances and intuitively know how we need to use them.
New devices and technologies, like robots, that are like companions, helping you live a fuller, happier life. To show you, I want to invite a special guest to the stage. Say hello to Barley.
Barley is another personal robot that uses artificial intelligence to understand its owner's commands. creating the right framework for a ball-shaped robot wasn't easy. Original plans to make the ball out of cloth were changed when designers realized this could be too fragile, especially if barley was anywhere near dogs. The hard, rich plastic of barley will stand up to considerable wear and tear.
This is a feature of a new personal care, designed to make your life just a bit easier.
So while we've upgraded from push buttons to voice commands, our desire for an easier life through automation is the same as our mid-century forebears. How will connected homes change our lives into the future? And what sort of home tech will future generations aspire to?
Hi, Bali.
As well as the home, the Internet of Things is set to make trips into the country safer. With the help of a drone, connected cars can warn drivers of poor visibility and other hazards on the road.
We've seen how the car is able to communicate with its surroundings in the city and now in rural areas too. In this pilot test, we added a drone that sends information to the cellular network, which sends it to the vehicle, and the driver can see the information displayed on the instrument panel. Drones will protect areas where there's poor visibility or have difficult access. We aim to employ technology to improve road safety.
Similar predictive technology is being integrated into city driving.
SAIAT's connected cars receive real-time traffic information from the traffic authority's central cloud, including information displayed on motorway panels or traffic light status in cities. The traffic light sends a signal to the authority's cloud about when it's going to change. The car receives this information and alerts the driver of its status, depending on driving speed. If it's about to go red, drivers can begin to decelerate. It works as long as you are driving below the speed limit, because the system doesn't alert the driver at higher speeds. It's important for road safety as an auxiliary tool that enables motorists to drive much more smoothly. We can accomplish the same as what we used to do with variable message signs on the roadway, but now directly to the car from any point on the road. We can reach everywhere in Spain.
Connecting cars to real-life traffic data will also benefit the development of driverless cars. LG's connected car allows travelers to spend time on more productive activities than driving. Car fleets are likely to include the ability to personalize and streamline the journey through facial recognition.
So it knows who I am. Now keep in mind, LG ThinQ knows where I'm at. Also, it gives me my seat assignment, and now I can go inside. Now the first thing I like to do when I get inside is I put my jacket into this clothing care compartment. Now this compartment is going to get rid of wrinkles, it's going to get rid of odors, which I really appreciate. It's going to get rid of dust and allergens. And the best part is, it uses pure water, steam, and no chemicals, so I should show up nice and fresh. Let me tell you a little bit about the connectivity of LG ThinQ. When I was at home not too long ago, I was watching a soccer game. ThinQ knows this. Now ThinQ also knows that I'm in the smart car, right? Because I did the verification. Now watch what happens when I speak kind of vaguely just out to my virtual personal assistant right here. Watch what happens. Hi LG, can you show me the highlights? There you go. So LG knew that I was talking about the soccer highlights and not something else. I could again just speak to my virtual personal assistant, or I can go ahead and press that button. The drinks rise up to greet me. Now, watch the screen and notice what happens as soon as I take a drink out. I'm automatically charged $2. Now the question is, how does it know that I'm the one who took it out and not my neighbor here or the person in front of me? Well, again, that is the virtual personal assistant up here, which can also read my motions and my movements. So it reads that I'm the one who took it out.
The technology behind connected cars and robotics sometimes appears seamless, as if there's no human intervention. But every aspect has been created by a human, making the relationship between artificial intelligence and mankind an essential collaboration. Creatives who combine art and technology are essential in a world where machines are so powerful.
My name is Madeline Gannon, and people call me the Robot Whisperer. So this is the first time I've ever visited a car factory and been surrounded by so many robots. How many machines are collaborating at the exact same time to manufacture these highly complex things? And the entire building is a robot.
Madeline uses robotic body language to develop connections between humans and machines.
As an artist and as a designer and as a researcher, I want to find ways to show that robots can not only be useful, but they can be meaningful to our lives. And that's really where the arts come in.
She sees robots as beings with mechanical minds and muscles, reminding her of ants working towards a common goal. Researchers aim to demonstrate that as well as automation, robotic technology can be used to expand and increase human capabilities. Science fiction tells us to be careful and not to create robots so intelligent they take over the world. But the reality is that artificial intelligence has the capacity to improve our lives beyond our imaginings. Partnering with virtual technology brings innovations and creative solutions. Repairs can be done remotely. Health conditions can be diagnosed without the need to visit a doctor's surgery in person. And safety testing can be done without risking people's lives. Virtual design allows greater precision and creative detail, easily shared between collaborators in different countries. The ability to test on the screen before committing to the road opens a greater range of possibilities and sometimes leads to transformative technologies. But just because technology was developed for consumers doesn't mean it can't be used in wider applications. Composite materials produced by the Italian sports car maker Lamborghini have been sent to the International Space Station. These materials are used in cutting-edge carbon fiber research.
The Houston Methodist Research Institute, we are very excited of having the opportunity to partner with other industries to perform research that otherwise could not be performed anywhere else.
From when we started in the early 2018, our collaboration with the Houston Methodist Research Center, we defined together that the most severe space where it's possible to investigate the behavior of our composite material was the space. We decided to send our CFRP on ESS station. In this system, it's possible to evaluate what happened in conditions that are the more extreme as possible, for example, with UV radiation, atomic oxygen, and the temperature gap difference that is one of the higher that is possible to have.
Automobile Lamborghini has a keen interest in testing their carbon fiber material on the International Space Station because it may set the foundation for 3D printed technologies farther down the road.
For the same reason, the Methodists decided to send the material on the ESS station because also they needed to check what happened in terms of biocompatibility of this material in this extreme condition.
This investigation will hopefully provide Automobile Lamborghini with insight on how to utilize their material beyond the automotive industry, as well as we hope that we will be able to leverage the same type of information for our research down here on Earth for biomedical applications.
We are very proud about the fact that we are the first car manufacturer to send our material on the ESS station. And due to this, to guarantee that in terms of performance, we have tested our material in the most extreme condition that everybody can imagine.
From the start of the electronic age, entertainment has been a key focus for innovation. The simple shapes that characterized the 1970s video game Pong have given way to games of astonishing realism. The acceleration of computing power that has been so beneficial to biomedical space research is also improving our home entertainment. It's estimated there are 2.5 billion gamers around the world, spending more than $90 billion a year. LG's Dual Play allows 3D TV users to see different pictures on the same screen when they don special glasses. Each racer sees their car on the full screen, and there's no chance to cheat. So, how is this possible? LG made the clever decision to put 2 left-eye 3D lenses in one pair of glasses and 2 right-eye 3D lenses in the other. A relatively low-tech solution that has a big effect on the screen. Players need to be at eye level for the technology to work, and the game needs to support either a top-bottom or a side-by-side split screen. The result is a realistic, high-res picture while you speed through the race against your opponent. Another innovation is the development of drones as nighttime spectacles. They're becoming popular with event organizers as they are less polluting, noisy, and flammable than fireworks.
This is the Intel Shooting Star drone, and it does one thing, and it does it really well, which is to light up the sky.
Intel's drone light shows have been flown at events like Coachella, the Super Bowl, and the Winter Olympics. Like fireworks shows, synchronized drone displays require intensive planning. But unlike fireworks, the drones can be reused, making them far more environmentally sustainable. Intel calls drone light shows an intersection between art, science, and technology. The drones can be programmed to tell the story of the event they are performing at. The most complex shows use around 500 drones to fill the sky with spectacle. The drones are programmed using swarm robotics, a technology that was originally developed by observing the behavior of creatures like insects and ants. It's this link to the organic world that can make a flock of illuminated, unmanned aerial vehicles seem natural and even beautiful as they swoop across the sky. Drones are also finding a home in the world of racing. The Australian Army has its own team that competes internationally. It's a mix of gaming and real-life drone operation. Racers wear first-person view goggles, enabling them to see the drone's point of view. Using a video game controller, they send the drone hurtling around the course, reaching speeds of over 100 kilometers an hour. The sport is growing in popularity and is now part of the Invictus Games, the sporting event for wounded, injured, and ill veterans and active service personnel. It's starting to interest major sponsors, attracted to the excitement of a sport that requires exceptional agility and aerodynamic knowledge. And finally, the first electric flying car racing series is in development. Airspeeder will see pilots flying electric multicopters to demonstrate the potential of new, sustainable aviation technology. The eVTOL speeders have been custom manufactured by Alauda Aeronautics, with performance and ability as their primary objective.
The world's first look at this very exciting
flying racing car.
Airspeeder is a glimpse of things to come as sports and entertainment continue to evolve in surprising and exciting ways.